always east to west. Always. Why? Why don't they go pole to pole? Go pole to pole. If you can sail around Antarctica that way, then surely you can sail around Antarctica this way. Yeah? Here's Google Earth. This is real, even though they tell you. Since the planet is quasi-spheroidal, a trip from one pole to the other and back again on the other side would technically be a circumnavigation, but practical difficulties generally preclude such a voyage. Why? Why is that? Why do they say you can't go around this way, under, and back up this way? Why is that? Here's Google Earth, a spheroid, like they say, because of the force of gravity and centrifugal rotation, 1,000 miles an hour orbiting the sun, says, and they tell you themselves, that this is the shape of the Earth. This. Yeah? The poles are flattened and the imaginary equator line, by the way, it's an imaginary line drawn to give you a north and south. This is the real shape of the Earth. So why? This is a photograph from Apollo 17. Okay? So this is a fake photograph then. Because they're telling you the Earth should be egg-shaped. I want you to go this way. We'll start in the UK. Go around the North Pole. Around the ice that's not there. We'll go to Australia. Then we reach Antarctica. And it's a bit tricky. Well, let's just go around it then. Go around it. Go here. Here. Round here. And back here. Why don't you go around the globe that way? What's wrong with going that way? What's so difficult? Why is it technically difficult to do it if it's a perfect sphere?
Plain and simple, we'd like President Bartlett to aggressively support legislation that would make it mandatory for every public school in America to teach geography using the Peters projection map instead of the traditional Mercator.
Why are we changing maps?
Because, CJ, the Mercator projection has fostered European imperialist attitudes for centuries and created an ethnic bias against the Third World.
Really?
The German cartographer, Mercator, originally designed this map in 1569 as a navigational tool for European sailors.
The map enlarges areas at the poles to create straight lines of constant bearing or geographic direction.
So it makes it easier to cross an ocean.
But
Yes.
it distorts the relative size of nations and continents.
Are you saying the map is wrong?
Oh dear, yes. Look at Greenland.
Okay.
Now look at Africa.
Okay.
The two land masses appear to be roughly the same size.
Yes.
Would it blow your mind if I told you that Africa is in reality 14 times larger?
Here we have Europe, drawn considerably larger than South America. When it's 6.9 million square miles, South America is almost double the size of Europe's 3.8 million.
Alaska appears 3 times as large as Mexico, when Mexico is larger by 0.1 million square miles.
Germany appears in the middle of the map when it's in the northernmost quarter of the Earth.
Wait. Relative size is one thing, but you're telling me that Germany isn't where we think it is?
Nothing's where you think it is.
Where is it?
I'm glad you asked. The Peters projection.
It has fidelity of axis.
Fidelity of position.
East-west lines are parallel and intersect north-south axes at right angles.
What the hell is that?
It's where you've been living this whole time. Should we continue?
Uh-huh.
So, you're probably wondering what all of this has to do with social equality.
Salvatore Natoli of the National Council for Social Studies argues, in our society, we unconsciously equate size with importance and even power.
When third world countries are misrepresented, they're likely to be valued less. When Mercator maps exaggerate the importance of Western civilization, when the top of the map is given to the northern hemisphere and the bottom is given to the southern, then people will tend to adopt top and bottom attitudes.
But wait, where else could you put the northern hemisphere but on the top?
On the bottom.
How?
Like this.
Yeah, but you can't do that.
Why not?
Because it's freaking me out.
There's all kinds of proofs right around you that show that the Earth is flat. A very simple one to think of is that we use plumb bobs to build buildings. In other words, to get the wall of a building going straight down, you'll take a string with a heavy weight hanging from it, and you make the building follow that string. That plumb bob will point to the center of a round Earth. That means that if you imagine that this was the correct Earth, you can imagine a plumb bob held here would point in that direction, and a plumb bob held here would point in that direction.
That means the buildings would be bigger on the top than at the bottom.
It would also mean that boats would constantly be sailing downhill. And invariably, in any discussion about the shape of the Earth, the first argument used in support of its rotundity is that as ships sail out to sea, the tops of their masts are visible longer than the hull.
The fact is, of course, that the light rays from the lower part of the ship are no longer reaching the shore.
Perhaps the most significant experiments were those carried out on a canal known as the Old Bedford Level. Located in Cambridgeshire, England, the canal is perfectly straight over an uninterrupted 6-mile stretch. While there, Parallax conducted many experiments, all towards one conclusion: to prove that the surface of the water in the canal was indeed perfectly flat. In one experiment, a boat carrying a flag rowed from one bridge to another 6 miles away. An observer with a telescope placed 8 inches above the surface of the water found that the flag and the boat were distinctly visible throughout the entire distance. If the Earth is a sphere with a circumference of 25,000 miles, then over a distance of 6 miles, the second bridge should mathematically be 16 feet below the observer's eye line. But in spite of the mathematical evidence, any further attempts to restore belief in the flat Earth seem doomed by one of the supposed great moments in modern scientific achievement.